Hi everyone, these are Math SL practice problems that were pulled from past IB exams for math, and these are 5 problems that were pulled. So we're going to start on, they're basically inverse and composite functions, and there's one with logarithms in it as well. Okay, so first of all, they give you 2 functions, f and g, and they want you to find these 3 parts here, a, b, and c. So g of 0 is, all you do is take this function and plug in 0, so you get 0 plus 3, and that gives you 3. And then for f of g of 0, that's basically f of g of 0. We already know that g of 0 is 3, and then you do f of 3. So f of 3, I'll do it down here, f of 3 equals 2 times 3 cubed plus 3. And don't forget to do PEMDAS, so it's 27 times 2 is 54, plus 3 is 57. So there's our 2 answers so far. And then they want you to find the inverse. So basically, to find the inverse, I'm going to write this with a y, f with a y. Switch the x and the y. And then solve for y. And so I'm going to move over here. So this is going to be x minus 3 equals 2y cubed. Divide both sides by 2. So I get x minus 3 over 2 equals y cubed. And then you're going to cube root both sides. To get, so this cancels that. So you get y equals x minus 3 over 2, which this is your inverse. Okay? Yeah, here's another problem from an exam. Very similar, but in this case they give you 2 functions. Here they say x can't be 4 because you can't divide by 4 here if you plug in 4. And they want us to compose f with g. So basically they want us to compose h with g. So my inner function is g of x. My outer function is h of x. So the function I'm going to write down is h. I'm going to write 5, and everywhere there's a x, I put parentheses. And I'm going to dump in g of x, which happens to be here. And I'm going to plug in 3x minus 2. 3x minus 2. I simplify this, I get 15x minus 10 over 3x minus 6. Alright? Now, basically they want us to take, part C, take this and set it to 0 and solve for x. So you get 15x minus 10 over 3x minus 6 equals 0. Okay, so when you cross multiply, what happens is when you cross up here, this goes away. And 1 times that is just that. So you get 15x minus 10 equals 0. So solve for x. I'll move it over here. So you get 15x equals 10. X equals 10 over 15, which is basically 2/3 would be your answer. And that's all you have to do. It's pretty simple. The next one is the log one. So first of all, I want you to find the inverse. So what I'm going to do is write this with y first. So y. Okay. I'm going to switch the x and the y, as with all inverses. And then I'm going to solve for y. So I'm going to start moving over here. I'm going to add 8 to both sides. Now in this case I'm going to take the natural log of both sides, and I'm going to work over here, this side. So basically I'm going to have ln of x plus 8 equals ln of e to the y minus 11. Now I'm going to use my power property and bring this out in front. So I get ln of x plus 8 equals y minus 11 times ln of e. Alright? ln of e equals 1. If you haven't studied logs yet, then you might want to skip this. But if you have, then you're good to go. So then I can cross that out. ln of e is 1. And then I'll just solve for y. Plus 11 equals y. That equals your f inverse. Okay, now the domain of f inverse of this, right here, what you're going to do is look at this part right here. The quantity here has to be greater than 0, so it has to be positive. So in order that to be positive, our domain's going to be x has to be greater than negative 8. Because for all logs, for ln's, the quantity has to be positive. Okay, the next question is very similar. We have f of g of 4. So first thing we're going to do is do this. And I'm going to do my inner function first and plug in 4. When I plug in 4, I get 1. So now then I do f of 1, because that equals 1. F of 1 equals 2. Now they want you to find the inverse of g. So again, all I'm going to do is write this as y equals 1 over x minus 3, and then switch the x and the y. So x equals 1 over y minus 3. Now I'm going to cross multiply here, put that over 1, get xy minus 3x equals 1, and from here you solve for y. So I'm going to have xy equals 1 plus 3x, and then divide both sides by x. So you get y equals 1 plus 3x over x. So that's your g inverse. It's right there. Now, the domain, we want it to be all real numbers, but the only thing it can't be right here is 0. Because you can't divide by 0, so x cannot be 0. It can be everything else but 0. Okay. The last problem is the hardest. It's more complicated. Mainly because it has a graph to go with it. So first we're going to find the inverse, and we'll go a little quickly here. You've got my switch the x and the y, and solve for y. So we get x plus 5 equals 3y. So y equals x plus 5 over 3. That's your f inverse. Okay, so that's my answer. Now, they give you the inverse of g. So they did that for you. And they want you to find g inverse of f. So basically, I like to write it this way. And they want, this is again the inner function, outer function. So I'm going to write the outer function down. The outer function is x plus 2. So everywhere there's an x, I'm going to put parentheses. And inside of that, I'm going to dump in f of x. Well, f of x is what? 3x minus 5. And when you simplify this, we get 3x minus 3. So this basically equals g inverse of f of x. All right? Right there. And we're going to use that again. Okay. Now, they said given that f of f inverse of g of x equals this, solve this. So basically, they're giving you this, so write that down. That's x plus 3 over 3, and they want you to solve it with this, which we already did. That equals 3x minus 3. So write 3x minus 3. You can cross multiply here, and you get x plus 3 equals 9x minus 9. And group my x's. Hope I did this right. So we get, I'm going to add the 9, so we get 12x equals 8. Did I do that right? No. 12, sorry, equals 8x. So x equals 12 over 8, which is, if you divide everything by 4, so let's just put 12 over 8, which equals, I'm working backwards here, so divide by 4, you get 3/2. Alright, so the answer is 3/2 there. You need to do this on paper because it kind of is hard to squeeze it all in. Now, they want you to graph this. They want you to make a new function at h of x, which is f of x over h of x, and I went ahead and wrote this out and graph it. So the first thing you need to know is your vertical asymptote is x equals 2. Because if you plug in 2 here, that's your domain, you get it undefined, so we have to make a vertical asymptote. The horizontal asymptote is, if you recall from your rationals, is that when the degrees of a rational are the same, you divide the lead coefficients. So 3 divided by 1 is 3, so that's y equals 3. So they're going to want you to write that down and then graph it. I went ahead and took the liberty of drawing the asymptotes. This is y equals 3, and this is x equals 2. Now, what you need to do is, right here is more of our center point. Take these two x values and plug it in. So plug in 3. If you plug in 3 here, you're going to get 9 minus 5 is 4. And 3 minus 2 is 1. So 3 goes to 4. So it's right there. And also plug in 1. So when you plug in 1, you're going to get 3 minus, it's going to be negative 2 over 1 minus 2 is negative 1, which equals 2. So that goes to 2. And if you notice, they're like right apart from each other here. They're kind of like that. And you just graph it from here like this. You should already know what a rational looks like. If you know what it looks like, it makes it easier. Now, if you want, you can plug in more values here. This was 2, right? And that's what it would look like. In this case, however, this particular problem, they want you to restrict the domain in the range. They want you only to graph between negative 3 and 7. This is 2, 3, 4, 6, 7. So they only want you to graph from here to here. I'm just going to make a little box here. And for the y, they want you to go to negative 2 to 8. And 8's about right here. So basically what I'm going to do, and this is how I would do it. If you're very visual, you can, I'm just going to erase what I did earlier. And I'm going to do this part last. Now, if you're visual, you might not have to do this, but I'm not. So this is how I would do it. Okay? And then that would be my restrictions. I went ahead and did one more problem here. In this case, I kind of set it up where we have the same thing. My vertical asymptote is x equals 1, so I put it right here. And I have the same horizontal asymptote. So this is y equals 3 and x equals 1. I'm going to go ahead and plug in 2 and 0 for my table. 2 and 0 right on either side of my vertical asymptote. Now when I plug in 2, what I get is 1. So I plug in 2, I get 6. So that's going to be 1. 2 minus 1 is 1. So 2 goes to 1. I hope I did that right. So that's 2, 6, 2. Yeah. And then when I plug in 0, I get 5, which is here. And I wanted to show you this because in this case, your graph is going to look more like this. It goes the opposite way. So you have to be careful there. So that's why, let me put this. So 2 went to 1 and 0 went to 5. That's a good way to graph. And you get an idea. Now, in this case, they want us to restrict from -3. Just, let me do a different color. -3 to 7. 2, 3, 4, 5, 6, 7. So from here to here. And they want us to graph from -2 on the y to 8, which is about there. Let me erase this piece here. All right. So I'm going to box in this area. And so what I do is I erase my excess here. And then I draw my arrows on the inside here. Okay. And that is all. That's 5 problems that you might run into similar to these on a Math SL exam. Take care.